Welcome to College Algebra number 3. We're going to talk about the commutative property, associative property, identity numbers, inverses, and expressions versus equations. Then we're going to finish up by working examples 10, 11, 12, and 13 on pages 17 through 24. We're still doing prerequisites, so that means all of this stuff should be stuff you've seen before, and this particularly for many years now, but maybe you didn't really understand it, so this is your chance. There are some properties of real numbers, and that means characteristics. There's things that happen with real numbers all the time, and that's why we call them a property. You're not going to, well, you actually use these all the time now, you just don't know you're using a property. So the trick here is going to be able to recognize the property when you see it on a quiz or a test. First, it's the commutative property. Now this property is only good for addition and multiplication. It does not count for subtraction and division. What does it mean to commute? When you commute, you go back and forth. So the commutative property just tells you that when you are adding or multiplying, your numbers can go back and forth and not change the value. In variable form, it says a plus b is equal to b plus a. In multiplication, a times b is equal to b times a. Now what does this mean for numbers? Well, if you have 2 plus 3, that's the same thing as 3 plus 2. Well, that makes sense, doesn't it? Now you see why this doesn't count for subtraction, because 2 minus 3 is not the same as 3 minus 2. In variable form, this would let you rephrase 2 plus a. You could say, well, that's the same thing as a plus 2. This is what lets us rearrange those numbers for grouping whenever we need to combine like terms. Same thing with multiplication. If you've got 2 times 3, that's the same thing as 3 times 2, right? If you've got x times y, that's the same thing as y times x. And that is the commutative property. Now let's do the associative property. This property is only good for addition and multiplication as well. Now what does it mean to associate? When you associate, you group together. What symbol do we use in math to show grouping? That's going to be your parentheses, brackets, braces, yes, but mainly parentheses. Now, the associative property says that parenthesis, a plus b, close parenthesis, plus c is equal to a plus parentheses, b plus c. And the same thing with multiplication. Parentheses, ab, close parentheses, c is the same thing as a parenthesis, bc. Now, like I said, you've been using these, you just didn't know that they were a property. For example, if I had 50 plus 3 plus 50, and I wanted to make this easier, I want to group the two 50s together and add them because 100 is easy to work with. So the associative property lets you know it's okay for you to pull this out and add it to the 50 first. You can reassociate as long as all of your terms are added or as long as all of your terms are multiplied. If I've got x times y times z with the x and y grouped, I can regroup that and put x, z times y. As long as everything's multiplied, it all comes out in the end. Pop quiz time. If on a test you had an equation that looked like this, parentheses 2 plus 3 plus 4 equals 4 plus 2 plus 3, and you were asked, is this the commutative property or the associative property? Which one do you choose? Well, if you said the commutative property, you are 100% correct. I catch a lot of students with this one because they see those parentheses and they automatically assume associative. They've learned that parentheses mean associate. But if you look more closely at this problem, what's grouped together here is the 2 plus 3. What's grouped together over here is still the 2 plus 3. The association within this equation did not change. What did change is the position. Here the 4 is at the end, and here the 4 is at the beginning, so it commuted. It moved. So the correct answer to this is commutative. If you got that right, good job. I know the distributive property is one you're all familiar with. Now, the distributive property is of multiplication over addition. So, for example, I have A times a set of numbers that are added together. So here's your multiplication over addition. And the distributive property says when you have a number outside the parentheses, you can multiply it times each number inside. We use this in PEMDAS for that very first step when you are trying to get rid of the parentheses. Now, for example, if I have 3 times 2 plus 5, I'm really not going to use the distributive property. For PEMDAS, I'm just going to add this together and say 3 times 7 is 21. But what if I have 3 times x plus 5? Well, my first step is to get rid of parentheses. I cannot get rid of parentheses by performing the operation in here, but that's when your distributive property comes in. You can get rid of the parentheses by distributing this number inside the parentheses. And I always say, pretend like this number outside is me with a box of brownies and this is my class. Everybody in the class wants a brownie. So I'm going to multiply 3 times x and 3 times 5 and get a simplified version of 15. And this is when you're going to use the distributive property. Next is identity numbers. These are numbers over addition and multiplication that when you use these numbers, they don't change the identity of the number you started with. So for example, in addition, if you add 0 to any number, you don't change its identity. For multiplication, you don't change the identity if you multiply by 1. Now, once again, this is more about knowing a definition. So if on a test they ask you what is the identity number for addition, you need to know that that's 0. And now our inverse property of addition and multiplication. This property simply states that in addition, there is a number for every number that when you add it to your given number, you get 0. In other words, negative a is the inverse of a. 7 plus negative 7 is 0. Every number has a number that's its opposite. If I give you 3 and ask you for the inverse, that's negative 3. Alright, the multiplicative inverse, or the inverse for multiplication, says there's a number for every a, and when I multiply it times a, I get 1. It's a little bit harder to understand, but if you take 7 and you multiply it by 1 over 7, your answer is 1 every single time. The reason is, what you do is you change this to 7 over 1. You've still got multiplied by 1 over 7. Look, your 7's cancel. You've got 1 over 1, which is 1. So the multiplicative inverse of any number is the number that you can multiply by it to get 1. If you have 1/3, your multiplicative inverse there is going to be the opposite. It's 3 over 1. So that when you multiply them, you get 1. Believe it or not, even decimals have a multiplicative inverse. There is a number for every number that you can multiply by it and get 1. Okay, expressions versus equations. I believe I mentioned this previously, but it never hurts to say it one more time. There's a difference, and it's very important. An expression does not have an equal sign. An equation does. So x plus 2 would be an expression. X plus 2 equals 7 would be an equation. You can simplify an expression. You can solve an equation. And I know that's just words and they don't seem all that important to you, but in math, words matter just as much as everywhere else. And this is going to be extremely important to you as far as knowing what am I being asked to do. So please get down the difference between an expression and an equation. Now it's time for me to go to work. This is example 10b from page 21 in your book. The instructions say evaluate t over 2t minus 1 for t is equal to 10. Now this is an expression, but we're told to substitute in a 10 for every t, every single one. So we're going to put 10 over 2 times 10 minus 1. Now, using PEMDAS, even though in these shorter problems you don't think through the steps yourself, that's actually what you're doing. There's nothing to do up here on the top. The fraction bar is our grouping symbol. So we come down here to the bottom. What are we going to do first? Well, we don't have any exponents. There's nothing to do inside these parentheses. So we're going to do multiplication and or division. I'm going to put 10 up here. 2 times 10 is 20 minus 1. And then nothing changes on the top. 19. Now, if I could reduce that down, I would. If there was a number that would go into 10 and into 19, but 19 is prime. Now let's turn to page 22. I'm going to work through example 11. And this is a problem using a formula. The hardest part about using a formula is knowing what the letters in the formula stand for. And sometimes they're easy to figure out, sometimes it's a little more complicated. But we are told that this is a right circular cylinder, which doesn't, mean a whole lot, but it gives us a shape. We're given the formula. We want the surface area of this whole cylinder. So we want to know the area of the top, the bottom, and the side, all the way around. And there's other ways you could do this besides using a formula. You could find the area of the rectangle and the area of the two circles. But the formula just makes it easier, plus they give it to us. And here it is. S is equal to 2 pi r, parentheses, r plus h. Now, we're also told to leave our answer in terms of pi. Whenever you see this, you are not going to convert that pi to 3.14 or 22 over 7. You're not going to convert it. You're going to leave the symbol pi in your answer. We're given the information that the radius is 6 and the height is 9. Now, fortunately, that's pretty easy to figure out for this formula. R is going to be the radius and H is going to be the height. So, let's fill in our formula. S is equal to 2 times pi times our radius is 6. And then in parentheses, 6 plus our height is 9. So here's what the formula looks like when you fill it in. Now all that's left to do is simplify. Remember, we're not going to convert pi, so we're just going to leave it like it is. Multiplication is commutative. Well, let's go through our PEMDAS. First, we're going to go over here and do what's in the parentheses. Now, what's 6 plus 9? It's 15. So right now, I have 2 times pi times 6 times 15. Now, like I said, multiplication is commutative. All three of these numbers are multiplied together, and you could get a calculator out and do 2 times 6 times 15, or you can use your commutative property. 2 times 15 would give you 30, and 30 times 6 is 180, and then you have pi. And that's going to be your final answer. You're not going to change that to 3.14. Moving on. Page 23, example 12a. The directions say simplify each expression. Okay, an expression means there's no equal sign. You're not getting an answer. You're just going to try to condense this. And if I were you on all of these problems, I would pause and see if you can work this out and get the right answer before I work it out. But anyway, we're going to go through here. How many terms do I have here? 1, 2, 3, 4, 5. Remember, terms are separated with pluses and minus signs. A sign belongs to the number that is behind it. For example, this minus sign belongs to that 2y. So wherever I move that 2y, I'm going to take that minus sign. Now, once you get proficient in this, you probably don't write down this next step. This is just something you're going to do in your head. I'm going to commute these numbers and move them around so that my similar terms are next to each other. So I'm going to have 3x plus this x. Then I'm going to have the minus 2y, the minus 3y, and the minus 7. Alright, let's combine. 3x plus x is 4x. A minus 2y and a minus 3y, same signs, so you add and keep the sign. So that's going to be minus 5y minus 7. Okay, example 12b. once again I have this expression, and once again, if you want to hit pause and see if you get the correct answer. Alright, going through here to use my PEMDAS first of all. I lock in on this set of parentheses. I need to get rid of the set of parentheses. Now this is what I was telling you a minute ago about your distributive property. I cannot do 3 minus r because I don't know what r is. But there's another way to get rid of parentheses, and that's using the distributive property. I can distribute the number that's out here. Now you have to be careful because, like I just told you also, this minus sign belongs to that 5. So let's just see what's going to happen when we distribute. The 2r is not going to change at this point. When I distribute minus 5 in here, a negative times a positive gives me minus 15. A negative times a negative gives me positive 5r. The plus 4 is not in the parentheses, so it doesn't get anything distributed to it. Now, I've gotten rid of all my parentheses. I'm going to move the numbers around and combine the like terms. 2r matches 5r, so I want to put them next to each other. This minus 15 and the plus 4 can go down here on the end. And this leaves me with an answer of 7r minus 11. Okay, now we're ready for example 12C from page 23 in your textbook. This is an expression and we're told to simplify it. So we're just going to be using PEMDAS to get this as condensed as possible. Now I see these 2 sets of parentheses, so that's my first step. I need to get rid of the parentheses. I can do that one of 2 ways. I can perform the operation that's inside, or I can distribute the number that's outside. When I look at this, I've got a T and an S, so I can't combine the terms, but I can distribute. But there's no number in front of it. Well, actually there is. The understood 1 is always out there. So I can distribute a positive 1 into this set of parentheses and still retain its value. That identity number, remember that? So 4t minus 5/4 s. But I do want you to understand, I performed an operation. I performed distributive property. I don't want you to think you can just willy-nilly drop parentheses wherever you want to. You can't. I multiplied positive 1, which is out here, times this. Now when I come down here, it's a little bit different because of the minus sign. What I've got to do here is distribute the minus, or a minus 1. And that's going to change everything that's inside the parentheses. Right now, because of the parentheses, this number's positive. But when I distribute, it's going to become negative, or minus 2/3 t. And this plus 2s is going to become minus 2s. So now I've gotten rid of parentheses. I'm going to use my commutative property to move my numbers around and get my similar terms together, remembering a sign belongs to the number that's right behind it. So when I move this 5/4, that minus sign has to go with it. So now I'm going to have 4t. I'm going to bring the minus 2/3 t over here. And like I said, you're probably not going to write this step down. A lot of this you just do in your head. So minus, let me go back and get the 5/4 s, and then minus 2s. All I did on this step is rearrange it so that my similar terms are together. Now I'm going to be combining terms, and this is going to mean that if the variable part matches, I can combine the coefficient in front of it. Now there's fractions in here, so I'm just going to use a calculator real quick. If you need if you're unclear about how to add and subtract fractions, you can let me know, and I'll get you some extra work on that. All right, 4 minus 2/3 is going to be 10/3 t. And down here, minus 5/4 minus 2s. Since both of them are negative, you're actually going to be adding, so that's going to be 13/4s. And now example 12D. We have 2mn minus 5m plus 3mn plus n. What we want to do here, there's no parentheses, there's no exponents, so we are into combining similar terms. Now when you have a term, the whole variable part has to match. Mn is not the same thing as m, and it is not the same thing as n. So I can't combine it with either of these, but I can come down here and combine it with the 3mn. So 2mn plus 3mn gives me 5mn. Now the rest of it, I can't combine anything with this, so I'm just going to leave it like it is, and I can't combine anything with the n. So that's going to be your simplified answer right there. Okay, we're ready for our last example problem for this section. Example 13, which starts on page 23 and finishes up on page 24. This is the perimeter of a rectangle, and you add all four sides together. They want us to simplify this formula. So let's add the matching terms. L matches L and W matches W. So L plus L is 2L and W plus W is 2W. Now, I would accept this as an answer, but the author of your book does insist that you go one step further and take out a greatest common factor. You are undistributing, in other words. So if you take out the 2 from both of these, then you have L plus W. Like I said, I have a little bit of a problem with this because in some circles, the presence of parentheses means that it's not in simplest form. But anyway, I want you to understand that these two things are actually equal. So, study suggestions at this point. Make sure that you have filled out your blank Venn diagram on number sets from video number 1. You have a packet of vocabulary terms that you can be working on. These are for all of chapter 1. We just did the first section. So these are for all of chapter 1. Don't feel like you need to do all of these right now. Just skim through here and see what you already know the definition of. Also, it's very important that you work some sample problems to see if you can do what I just did. I advise you to work multiples of 3 on page 24 and 25 in your textbook and check your answers. If you're getting them all right, fantastic. You know, remember, this is prerequisites. This is stuff you should already know. So if you do, you're on target. If you don't, let me know. Okay, we need to remediate now so that you don't have a problem when we get into chapter 2. You were champs for hanging in this long, and that concludes chapter 1.1. Next video we'll go into chapter 1.2. That's going to be fun. See you there. Bye.